Okay, so welcome everybody from the plenary session, and just so we are all in the same location, this is breakout topic 1, using improved exposure, vulnerability, and hazard data for forecasting disaster risk today, tomorrow, and beyond. I've been thinking about what is beyond tomorrow, but I often don't think that far. So there's 2 moderators. There's myself from King's College London, and I'm part of the LANDSLIP and 4PAC grant. And then Stephen, you want to quickly?
Yeah, hi. Yeah, Steve Cole from the UK Centre for Ecology and Hydrology, and I'm PI for the NFLICS project, which is one of the Catalyst grants.
Okay, lovely. And there's about 20 of us right now on this session. So what I'm going to do is I'm going to start us off, and we're going to start off with just a very brief recap of DRR related data that I'll do. We're then going to have 6 SHEAR grants are going to do 2 minutes of flash talks. And everything is on this Padlet here. There's not a chat function. So I've created a tiny URL, tinyurl.com/SHEAR-breakout1 for you to go to. After the flash talks, you'll have an opportunity to ask questions. We're going to ask you to use the Padlet for the flash talk speakers. And then we have 3 questions for the participant and panel engagement, and then we'll do a summary. So kind of a quick schedule here. So I'm going to go ahead and start quickly with a very brief recap on DRR related data. Many of these are things that we all know. It's just to remind ourselves about the themes of when we talk about data, the context we're talking about it for disaster risk reduction. So we have hazard intensity and frequency. There's many examples. We have records of past events. So for instance, in Nairobi, where are the seismic faults? For floods, what's the basin topographic characteristics? How much rain there is? We have vulnerability, and these are the characteristics of the people or the infrastructure, census data, physical characteristics. We have exposure, and this would be the assets that might be harmed. And so we have ecosystem services and people and power. And it's both where people are and when they are. And both vulnerability and the exposure can be dynamic in time. And this is something that has come up in a lot of the grants. And then we have disaster impact. There are many examples. You'll see some of these in the flash talks. And then also there are some global databases, Desinventar, EMDAT. We have the Global Fatal Landslide Database, Dartmouth Flood Observatory, and there's many of these. Now, there's many other types of DRR-related data. We have protocols and regulations, communication types, equipment, resources, stakeholders, and many other types of data that might influence DRR. And these are just some examples of some of the data types. Some of these we will find discussed today, ranging from videos to citizen science to instrumental records to responder reports. And then what does DRR-related data help inform? And that's one of the purposes of our breakout session is it can help inform early warning tools, impact-based forecasting models, risk assessment, and then we get into all of the others, better use of resources, policies, and then one of the major ones, which is planning and mitigation for risks in the future. So what will a region look like in 20 or 40 or 80 years as it grows up or out? So with that, that was a very brief recap. And what we're going to do now is we're going to go into 6 flash talks given by 6 of the SHEAR grants, and we appreciate very much their agreeing to do this. We'll start with LANDSLIP, then we'll go to WEAC, COSMA, Connect 4, WR, Fathom, and NFLICS. So I'm going to turn over to Steve now, as soon as I stop sharing the screen. Okay.
Thanks, Bruce. I'll now have a go at sharing a screen.
Good.
Okay, so hopefully has that come through? Can you see?
Yes, it has.
The landslip. Brilliant. So first talk up is landslip, and Ramesh, would you like to go ahead and?
Yes, thank you very much, Steve, and thank you, Bruce, for inviting me. Hello, everyone. My name is Ramesh Gunta from Amrita University. Today, we'll briefly talk about the landslide occurrence tracking methodology using citizen science and crowdsourcing through a mobile and web app to enhance the Indian National Landslide Database. Next slide, please. So in India, there are a lot of widespread landslide occurrence, especially during the monsoon season. And recording the landslide right after it occurs is very critical to gather data accurately and also help in relief operations. So the initiative for systematic landslide tracking methodology and corresponding mobile application was funded and carried out under the LANDSLIP project. The methodology can be, a snapshot of the methodology can be seen in the figure B, and figure C shows the snapshot of the mobile app. The mobile app software is done by Amrita University, and the content for the mobile app is provided by the LANDSLIP partners together. And much of the content mirrors the landslide tracker form, which forms the paper-based tracking method. And the methodology and the app facilitate a collection of landslide information through citizen science, and it allows for various levels of citizens such as volunteers and NGOs, officials, and experienced subject matter experts to track the landslide through different levels of questions. And also the landslide tracking, it tracks the GPS location, date, time of the occurrence, images, questions, and also a lot of technical details such as landslide type, material, size, impact, etc. And the collected data is available for everybody, and especially contributes to the National Landslide Database. Next slide, please. And specifically, the app prompts the user to enter the questions, answer the questions related to the particular landslide, such as location and landslide type, material, and everything. Along with, we also provide a glossary and documentation to refer to various questions. And we also provide sample images next to each type of question so that user feels it easier to fill the form. And we offer the interface in multiple languages, multiple Indian and foreign languages also. And users can, after the landslides are entered, users can access them through multiple interfaces, through images, through map interface, and also through spatio-temporal summarizations, and also summarized by different types of landslides. For example, if you want to find out the locations, how many landslides were collected that are having the material type of rock versus debris, you can find out that.
Thank you very much, Ramesh. We'll move on to the next talk now. So thank you.
Thank you very much. Thank you very much.
Okay, so next on the list, Chen from Loughborough. Would you like to go ahead, please?
Yeah. Can you hear me?
Yes, we can hear you. Yeah.
Okay.
Yeah.
Great. Hello, everyone. Yeah, I'm Chen, a lecturer from Loughborough University. Yeah, today I will briefly introduce our work on assessing the impact of glacier lake outburst floods. Yeah. Firstly, about hazard assessment of globes. Traditionally, proxies of globe hazards are extracted from the increasing DEM and remote sensing data. At the same time, a range of numerical models have been developed to predict the dynamic process of globes. But for exposure estimation, currently it usually happens by using sensors data at coarse spatial resolution or land use data aggregated across many objects. but such spatial resolution are not detailed enough for the mitigation of gloves risk. Therefore, we developed a new assessment framework. Here, empirical dam bridge approximation model has been used to estimate the outflow discharge, and then the outflow discharge will be used to drive the GPU-based hydrodynamic model. And then the spatial exposure data has been collected from different source data. It can detail the types and locations of different objects. And also some tradition impact evaluation methods are used here. Next slide, please. Yeah. By using this assessment framework, we can identify how many villages and which village are faced with high flood risk, and also how many buildings and which building, the building's location, and how many agriculture area, how many roads will be impacted. And also we can identify the key facilities like schools, hospitals, airports, hydropower plants that can be potentially impacted by the global risk. And also we can provide a detailed flood hazard map for representative settlements. Overall, this potentially exposure objects can be site-specific, evaluated with very clear information on hazard degree, which can be used in mitigating the risk of gloves. Yeah, thank you.
Thank you very much. So on to the next talk, Dr. Lewis Blunn.
Yep, thanks, Stephen. So yes, I'm Lewis Blunn, and I was a postdoc working on the COSMA project last year. I'm presenting in place of Dr. Vincent Luo, who's the PI of the project. Next slide, please. So Sri Lanka is a South Asian country that has hot, humid climate, and it commonly experiences frequent heat waves that are very intense and long lasting. And that makes humans at high risk of mortality, heat-related mortality. So the urban design and the design of individual buildings greatly influence the outdoor and indoor temperature. So as part of the project, we are modeling and observing temperatures, and our vision is to inform how we can integrate urban building design for healthy living in response to heat waves. Next slide, please. So our approach involves using a multi-scale urban climate modeling framework. So due to a scarcity of data in Sri Lanka, we spent a lot of time creating land cover and urban form data sets. This is involved using satellite data and machine learning techniques. And personally, I spent a lot of time creating a anthropogenic heat emissions model, which I will be publishing shortly. So these are used as inputs to the Surface Urban Energy and Water Balance Scheme, SUS. And we've used to make temperature maps over Colombo. And we've evaluated these using temperature observations. And initial results show that largest temperatures are seen where there's most built up areas. So we've coupled these to a building energy model. And this we're using to investigate how changing the building design influences the indoor temperatures. And this is also subject to a paper coming out shortly. So working with our Sri Lankan partners, we are using the city scale temperature maps and the building scale modeling to inform how we can create a better, more comfortable environment. Thank you.
Thanks very much, Lewis. And just a reminder that on the Padlet, there's an opportunity to put questions for any of the flash talks that you're listening to. Okay, so over to you, JC, for Connect 4, please.
Thanks, Stephen. Hi, everyone. So yeah, so some overview of our Connect4 research project, and on behalf of the whole team, a bit of element of our research, which is still ongoing. So Connect4 project is looking at floods and droughts in the Limpopo River Basin in Southern Africa, which is highly vulnerable and increasingly impacted by these events. And I'm going to present you the approach we use to look at hazards and vulnerability in particular, and some of the modeling we do to increase resilience, water resilience and adaptations. We're not really directly looking at forecasts. Next slide, please. So the work we do is a kind of a multi-proxy approach to understand floods and droughts. We use a variety of techniques which we integrate together. So in particular, something we've done is to look at sediment archives through sampling some dams across the basin. So dams and sediments are interested because they give information on very impactful floods events, in particular where there's been a lot of erosion and redeposition associated to that. We obviously looked at hydrological data, various types, from river discharge to groundwater level to rainfall and so on. We've also did some governance and community interviews in various parts of the basin. And we brought all that together through a various stakeholder workshop, including a large transboundary stakeholder workshop, which helped us to build and develop a hydrological model with stakeholder inputs, and in particular design some management scenarios for adaptation. Next slide, please. So all of that brought a number of interesting findings, which we're still working on. In particular, bringing together this multi-proxy approach gave some interesting insight on the drivers of floods and in particular the impactful ones. So we realized that rainfall and discharge are not necessarily always very well correlated with the most impactful floods. And the information from dam sediment and from community is very useful to track them and reconstruct them a little bit better. We found also that after severe droughts, the floods are usually more severe and impactful. And we found that there's an interesting correlation between droughts and groundwater decline, which we know is related mostly to abstraction. So there is an interesting role of looking at groundwater status as a proxy. And this is something we investigate a bit further through modeling, in particular with the stakeholder co-created model with stakeholder. We test a range of scenarios with a specific focus on looking at this groundwater indicator and look at how we could capture, in particular, floods and extreme rainfall and aquifer storage, and see what this scenario implies in terms of groundwater level and potentially drought mitigation. So that's a bit it. Thank you.
Thank you very much, JC. So over to Simpy Wei, if you'd like to present.
Thank you very much, Bruce. We can immediately go to the next slide. So this is a brief sort of overview of a study that we, pilot assessment that we conducted at the Red Cross under the Fathom project on various types of vulnerability in South Africa, Uganda, and Mozambique. And the study really began more qualitative in relation to the other flash talks. The study really began as an idea to think about and to better conceptualize vulnerability. So you have on the left this timeline of vulnerability, and you can see that institutional approaches, especially in the humanitarian space and overall in the climate change literature, have gone through several cycles of trying to understand, identify, and assess vulnerability. So we have this evolution of vulnerability from a methodological approach to a system of analysis, and finally to this interdisciplinary or multidisciplinary approach to understanding issues of exposure, sensitivity, and adaptive capacity. Now, what we found is that because of these varying conceptualizations of vulnerability, vulnerability has sort of become a catch-all phrase to think about how populations experience or respond to the impacts of climate change. And the overarching goal of the study was really to decouple exposure, sensitivity, and adaptive capacity so that we could better engage with how discrete populations experience exposure, sensitivity, and adaptive capacity to climate change risks. We can go to the next slide. This led us to think about how discrete political identities, for example, LGBTQI+ communities, urban refugees, and unemployed youth in parts of Uganda, Mozambique, and South Africa, respectively, might experience climate change impacts or disasters such as cyclones, floods, and drought. And to really start to think about how this broad stroke or this broad brush idea of vulnerability might miss discrete experiences of these political identities. So while the quantitative data in terms of forecasting and anticipatory action support an initial evaluation of potential climate change risks, what we do find is that we tend to overlook lived experiences that might change across geographies, time, and space, even across communities living in the same country. So at the points at which political identities, so refugees, unemployed, or LGBTQI+, begin to interface with the governance system or the political structure, or even other communities in the space, their ability to respond to climate change impacts tends to change and tends to be different, which requires a discrete or a unique organizational approach to each of these risks and each of these groups. So broadly speaking, what we found is that local is important, that thinking about and leveraging local experiences, local responses is especially crucial in terms of addressing vulnerability because of issues like linguistic isolation, like access to income, access to capital and information, which tend to change across populations, even in the same country, as I mentioned. So I can speak more about the discrete case studies if there are specific questions about one or each of them, but that's the sort of overview of the assessment that we did. Thanks very much, Stephen.
Thank you. Okay, so final one is me. So sorry, you got to hear from me now. But we're looking at nowcasting flood impacts of convective storms in the Sahel. So just a little bit of motivation. Flash flooding from these heavy rainfall events is a cause of major damage and loss of life in Africa. And they come from these mesoscale convective systems, so these large systems that come from the Sahel and move from east to west. And if you look at past satellite data, you can see the sort of trend in the frequency of these events increasing over time. So over 30 years, they've increased by a factor of 3. So there's great potential to use satellite data to provide better nowcasts of what might be happening over the next 6 hours. So that's a low cost way of getting into being able to nowcast forwards. But within this project, we've been engaging with the Meteorological Agency of Senegal, so ANASIM, and other local stakeholders on how they use this sort of information. So focusing on the bit to help with the forecasting side, we've been looking at the sort of risk, hazard, exposure, vulnerability, and it's a challenge in trying to apply some of these things to impact-based forecasting. But what the data that we had available was to look at flood impacts for certain scenarios based on historical data from major floods, and also modelling that's gone into looking at the impact of interventions that have been put in place since. On the hazard side, we can look at the probability of these mesoscale convective structures moving across the Western Africa, and you can see this Senegal here with Dakar, the capital, that has particular urban flood issues right on the peninsula there. And we can combine this information on convective activity with past records on rainfall data to estimate what the probability of getting flood producing rain. And then the sort of risk approach that we're using, where we're using the sort of flood impact matrix type approach. So you have a combination of what the potential impacts might be across the bottom, and then the likelihood of that occurring from this nowcasting capability. So this combines together to generate detailed impact-based forecasts for the area of Dakar, and we're providing that through various means to supporting the ANASIM, the Meteorological Agency. So there are web portals, but also in-house software that's running these. So yeah, if you want to hear any more, please get in touch. So Bruce, I think we're there in terms of the flash talks. I'm hoping you've been able to have a look at the Padlet, because I was unable to look at the Padlet whilst I was sharing the screen.
Okay, so what I'll do is I'm going to just share a screen again. And Stephen, are you able to see the screen okay?
I can't see your screen yet.
Okay. Let's just see what's going. Got the wrong one. Okay, so you should be able to see it now.
Yes.
All right. So what we'd like to do right now is, if people have questions or comments, we're first going to try to go to this Padlet, and the Padlet is here. It's tinyurl.com/shear-breakout1. And we're going to use this for the rest of the session. I'm just going to enlarge this so you can see it a little bit better. And so it's tinyurl.com/shear-breakout1. And what we'd like to start out with is, if you have any questions or comments for the speakers, if you would just click on the plus symbol here, then you will be able to add your questions or comments. So there's about 22 of us in total, which is a good number for having a discussion. And it's just a few too many to start unmuting people. So we're going to do it this way. So go ahead and join that. And I see a few people are now in the Padlet. That's great. And if you could start adding to this, that'd be great. And we have about 25 minutes where we'll do questions, and then we have some questions for you. So let's start off with questions for the speakers. All right. And it'll take just a minute for these to appear.
Bruce, can you move to the page with the web link? Yeah, thanks.
So this one here, sorry. So the web length is this one here. And actually, I'll just put that in the center so people can see it. There. You're right, thank you. It's the nice thing about having control on this Padlet.
There we go. That's good. Some questions coming through. Okay, so first question for you. Well, you've got a couple, JC. So first one, picking up on that comment about there not always being a correlation between rainfall and discharge. Yeah, if you want to expand on that, that would be really useful.
Yes, thank you. I expand by talking, right? Or
oh yeah, of course.
Okay. Yeah, no, there is usually, but for the extreme events, the highest rainfall intensity do not necessarily always translate into the most severe floods. That's what we see. So there is a correlation, but not always in intensity. And in fact, what we found, I mean, it's not a new thing entirely, but what we found is that the most disastrous, the most impactful floods events are usually just immediately following the severe droughts, regardless rainfall intensity. I mean, it's complex, especially in a large basin, but that's an interesting thing that seemed to be consistent across the basin, particularly from social data, so from people accounts and memories, but also from sediment data in particular, which relates to the most destructive events.
No, that's interesting. So maybe it ties into Linda's question afterwards. And so are the biggest floods, so like the largest magnitude floods in terms of flood flow, are they associated with the biggest impacts, or is that relationship different as well?
if the biggest floods are not always actually. Often this is the case, but that's not systematic. So that's why the pre or drought condition play a role, because you know, for the same floods and inundation levels, when soils and groundwater level are much drier, then it translates in more impact in terms of sediment transport, for example. That's what we found there, and then more impact also on infrastructure and things like that, because also of the erosion and the sediment loads that can be transported.
Brilliant. Thank you very much for that, JC. And I think we've got another question come through for Cosma. So the question is, could you elaborate on how these efforts have translated into action in Sri Lanka, and how are the findings currently being used?
Yeah.
So,
okay.
Lewis,
Thank you.
yeah,
So I think basically I'm not the expert on this, I'm afraid. I'm sorry. So you should probably get in touch with Vincent Luo. But I know that we're working with building designers and building planners, and we're sharing our heat maps and our anthropogenic emission predictions with them, and our building energy simulations. So yes, like they're giving us information on what a sort of typical Sri Lankan building might look like, and informing how we can do our building energy model simulations so that they can be most useful for them.
Maybe I had a quick follow-up question, if that's okay. I was just wondering if the is there any relation to energy consumption as well, in terms of that reducing things to, you know, like the net zero agenda? Is there sort of consequences for AC, air conditioning and those sorts of things, so that like the costs of cooling the buildings?
Yeah, this is one of the interesting findings actually from this paper that I'm currently writing, is that actually in South Asian countries, the anthropogenic heat fluxes are actually a lot less than you might expect, because it's because it's low latitude. You don't need much space heating, because it never really gets that cold in the winter, and in the summer people typically don't use air conditioning because it's expensive and you need a lot of electricity, so the electricity grids aren't always there. So actually one of our key findings is that the metabolic, because it's often high density, population density, these cities, that a lot of the heat emissions are coming from people and transport rather than from air conditioning.
Okay, thank you very much. So maybe there's one more question, and it's for me, if I can answer that one, about how the impact-based NICAS have been used. So thanks for that question. So yeah, so we've been working with ANASIM and working on communication strategies, so interacting with local stakeholder groups and community groups, and looking at those pathways of how information gets through, and trying to help ANASIM and others improve that flow of information. But I can give a sort of concrete example from last year. So in September last year, we ran a nightcasting test bed. And during that period, they were evaluating new nightcasting products, including NFLICS. And they actually issued a warning through SMS. They have various methods of disseminating warnings, but they have an SMS functionality, and they sent out a warning to 2 million people across Senegal of the risk of heavy rainfall coming in and impacts associated with that. So yeah, so there are it's things that they want to do more with, and we're at the start of that journey, but they've got the capacity in-house now to use this information. Okay, Bruce, what should we do? We've got a couple of questions for Simply Way. Have we got time for another one?
Yes.
Okay. So so what can be improved in data collection around vulnerability to be more inclusive? So I think a nice follow up to your talk there. Simply Way, if you'd like to, feel free to respond?
Sure. Yeah, I think the salient point about data collection, right, is that data collection is quantitative and a lot of it is statistical in the space. We're not going to be able to reach every single person to ask about their experiences of climate change risks, but what tends to happen in terms of targeting and in terms of evaluating risk is that we rely on aggregated national data sets, which tend to overlook issues, interests, populations that aren't necessarily in some cases that aren't necessarily safe in that space. So for Mozambique, for example, we looked at LGBTQI+ groups. And while Mozambique has a relatively friendly or safe regulatory and political framework for LGBTQI groups, so there is some data available, a place like Uganda, for example, has a fundamentally different perspective sort of policy-wise to LGBTQI groups. So that changes the types of data that we have and the types of information we have, especially about adaptive capacity, and so the types of interventions that LGBTQI groups might need. So I think one of the answers, and I mentioned it in the presentation, was about looking at local level risks. And one of the recommendations from the 3 case studies that we did was about ensuring that anticipatory action, and certainly the development of anticipatory action plans, engages or includes civil society groups or organizations that directly interface with these sort of political identities. And so from that, you get this idea of vulnerability as a process unfolding in stages over time. So while national data sets and statistics might give us a picture overall of what types of risks and hazards exist, at certain points in a disaster risk response, whether it's before, during, or after humanitarian crisis, for example, the types of salient issues and the types of discrete experiences that a population has are going to be fundamentally different. And they're going to be accepted or made space for in different ways, depending on the sort of regulatory framework that we're thinking about. So the 2 main things I think that could be done better, and certainly that we found in the pilot, were around engagement with particular groups and making sure that there's representation, and then really looking discreetly at the local level, which is why that idea of tackling exposure, sensitivity, and adaptive capacity become especially important, because that will guide what types of questions you're asking at the local level.
Okay, thank you very much. That was a really useful, I think, nice end to that discussion around the flash talks. So, Bruce, are we happy? I think this is a good point to move to the next part of the session.
Yeah, so I think what we'd like to do now is to hear more from the rest of the people that have joined this call. And what we've done is we've put together 3 questions. The first one is around collection of data. The second one is around use of data. The third is around where to put future funds. And we'd like you again to go to this Padlet. So tinyurl.com/shear-breakout1. And go ahead and start putting your comments. And let's start out with collection of data. You can also add them to the others after you're done with that. But if everyone who is in the group now, including panelists, if you would like to, if you would start putting things down here, and then we can start discussing a little bit, well, what is innovative about the data that we collect, how we use it, and where really should UKRI, the UK granting agency, be putting future funds? So just give you a couple minutes, a few seconds to put things in the chat here. I don't see anyone else there. There's one person.
No, I think that's good. Let's get that last question's ready for Tim's talk this afternoon then, where he's telling us the future funding opportunities. We'll have some ideas.
That's great. Okay, there's 2 people, 3 people. And then if any panelists you want to come in, please do for commenting on things. I think this, for me, as we're waiting for things, I think where innovation is often coming in these days for collection of data is recognizing the power of using citizens and local people to help enhance national databases and regional databases, and that the data might not be the best possible. It might not be the best that can be done by experts, but it is still very, very useful for us better understanding certainly the hazard and sometimes the exposure, and to an extent the vulnerability. So I think that is really an innovative thing that can be done. We've certainly done this in LANDSLIP, and I've seen other grants doing this, but it's still not taken seriously sometimes by the expert, this idea of citizen data. So I'm just waiting here, and okay, we're getting one there. I'm just going to refresh the page and come back over. Go. Okay, I'm not seeing them underneath here.
I think they're very small. I'm not sure how you can scroll down on the screen sometimes, Bruce.
Yeah, I am scrolled down.
Yeah, there are some there in a small box at the bottom. You can just about see the top of the box under the first question. On your, yeah, you can just see a very thin line.
Oh, I know the problem. Yeah, it's this. It's
Zoomed in, been zoomed in. Yeah.
Okay. Okay. So, Stephen, over to you.
Okay. Yeah. So we're starting to get a few ideas coming in. So, simply way. The Red Cross. Yeah, from the Red Cross Climate Centre. I think picking up a bit on what you were saying as well, Bruce, about coupling quantitative data with field research interviews, regional, local level desk research. I think it's this broad spectrum of sources that aren't necessarily always the government official sources or the global sources that are in the NDAT databases and things like that, that there's actually a lot to be gained from these alternate sources. I think there's another comment somewhere around things like use of social media and Twitter information. Is another example where there's opportunities to collect alternate information on particularly on impacts. I know there's quite a lot done in the UK on that, and looking at things like surface water flooding. But there's also been working around the world. So I'm just trying to scroll through and see some other comments coming in.
So we also have We Act here, and we also have a comment from LANDSLIP from Ali.
Okay, yeah, so yeah, brilliant. So for We Act, yeah, so merging these different sources again. So I mean, the initiatives like OpenStreetMap and Google Earth and those sorts of open sources are really quite powerful to be able to use in different types of assessments. So I fully agree with that. And yeah, I like what you've done within that modelling of seeing how to use those hazard maps that can be used for sort of flood preparedness, as well as perhaps in the moments when you think a flood might be more likely from these outflows. Being able to add that extra information about not just saying what the hazard footprint is, but looking at those potential impacts is clearly of great value.
Okay, so why don't we move on to the next question, the use of data. And it's basically, what examples can you give from your SHEAR project or other Global South project in your experience as to how DRR related data has been used in an innovative way to forecast disaster risk today, tomorrow, and beyond? And put your name and other information here if you'd like. And if any panelists would like to come in on this, just speaking. So Stephen, would you like to?
Yeah, I could say something. Yeah, okay. So I think one of the things that we found is trying to produce a system that that is achievable for the operating agencies to run. So we were really keen to have something that they could operate in-house and have ownership of and developed in that sort of true co-development sense. So in doing that, the source of the hazard data, having it driven by satellite information is quite attractive because they don't have to run large infrastructure, observation infrastructures or a very complicated NWP model to produce these sorts of nowcasts. All it needs is the feed of satellite data to drive it. So that was part of the considerations of how we were putting our system together, or perhaps a constraint on how we wanted to create a system that would have longevity and that ability for them to continue owning and using beyond the life of the project. So maybe a slightly different twist, but that's one of the things that certainly came out of our project.
Thanks. And if we just go back to the innovative data for a moment, we do have another comment here from Cosma, from Lewis on urban morphology data. And this was actually, Lewis, do you just want to speak to that?
Sure, yes. So one of the problems we had at the start of the project was there wasn't much land cover data or urban morphology data for Colombo, but we did have building data for a limited area. So that was our sort of truth data, if you like. And then we used satellite imagery to predict what the land cover and urban morphology was. And we could train it using, in machine learning, we could train it using that location and then make a more complete land cover and morphology map based on that training. So that's what we've used in as input to our model. I think it's quite unique in that there's very few data sets in the region at the moment. And I mean, perhaps it could be used in, not just in Colombo, the technique could be used elsewhere.
Excellent. Okay, for use of data, we're not seeing a lot of people put things in.
There we go. There's a good detailed one from Fathom. So okay, I'm gonna digest this a second. Yeah, okay. So the challenge, yeah. So I guess there are a lot of global initiatives around hazard forecasting and warning systems. But again, it's about coming back to some of these questions we had on some of the earlier talks, is about, well, how are these actually being used and how are they useful at a local level or in-country level. So I think that's talking to that challenge a bit about how you add the additional information you need on top of those sort of global products to make it relevant to the local community or the local stakeholder or that local level that you need to get to take the action at.
Okay, thank you. I think for the very last part, we're going to take 2 minutes, and it's if UKRI had £2 million to spend on enhancing methodologies for collecting and are using relevant DRR related data in an innovative way in the Global South, what would you propose? And what we'd like to ask is, could everyone just write 2 or 3 words, not a long thing, but just where should funding go? Just think of the bullet points, the main thing. Where should money be going for new data, innovative data, collecting data, that it's not right down. And I'm going to put my own, which is promoting open source data initiatives. So I've put one down. And it's kind of thinking about where is the future going when it comes to data. So AI for systematic mapping, that's Ali. Quantitative data for quantitative analysis, global landslide tracking, which would be rather interesting. Keep them coming in.
This is really good. This is good.
So merging global and local data, developing tools that could be scaled, used for other purposes. Some of these are fairly high level, but yes. And think about where this money is going, because there is going to be future funding on SHEAR type initiatives. And so there will be chances. Transferability of methods, I like. Internet access to cellular phone networks, centralized rural local phone points, excellent. I was going to put in, and I just forgot it, dense temperature observation networks, wonderful. And then we're getting into capacity development to enhance local capacity, develop use emerging technologies, good. Ooh, we're getting a lot here. We should have done that before.
Yeah,
Put two words.
Yeah,
we're storing data in a common, easily accessible place in country, funding to build capacity and get relevant data, identify data flows. That's interesting in difficult political situations. So thank you for that. That was excellent. And I think we're actually going to draw the session to a close, and I can never figure out how to stop sharing. Adapt models to work in situations with scarcity of data would be a nice one. Steve, can you very briefly share your screen so I stop sharing my, I found it. It's on my third screen.
Yeah, well done.
So thank you, everybody. This was a very quick breakout session. We really thank the speakers, the 6 speakers, for doing the flash talks and really getting them down to 2 content slides is not trivial. So we really appreciate you trying to encapsulate your thoughts into just 2 slides was great. And then for serving on the panel. And then thanks for everybody else. And then I'll just turn over to Steve for any final words.
Yeah, I was just going to say, really echo what Bruce said there. Thank you, everyone, for your engagement. So all the panel speakers and panelists, but also the wider group that's contributed. I was particularly impressed in that last 2 minutes. That was very fruitful. So I think, as you said, Bruce, something to think about for the future in running these sessions. But the Padlet will stay there as a sort of capture of what we've discussed today, and there'll be, if there's anything you want to follow up with a particular speaker, there's contact information there, so please do. But thank you everyone for all your contributions. So I think, Bruce, do we just leave?
I think we leave and we go back to the plenary.
Yeah. Okay. All right. See you back there.
All right.
See everybody back there.
Bye, everyone.